All right, welcome back. We'll be starting our discussion on Chapter 11. Chapter 11 from our textbook. Chapter 11 is all about inheritance and composition. In this chapter, there are a few terms we'll be discussing, such as what is a base class, what is a derived class. So we'll have a pretty good understanding of these two types of classes after this chapter is over. We'll also talk about, not in a lot of detail, but briefly, single inheritance, and our focus will be mostly in the single inheritance. We'll be discussing multiple inheritances as well. And there's something called public inheritance, briefly discussed in this chapter. Furthermore, we did talk about these identifiers, private, public, and protected. Today we'll be using protected identifier as well, and we'll see that what is the role of protected identifier in inheritance. Now, if I ask you, what comes to your mind in inheritance? So inheritance, when you inherit something, as an analogy, you can inherit some of the properties and attributes of other individuals, such as your parents, grandparents. You can also inherit some of their traits, some of their habits, some of the things they do, some of the way they say it, the way they talk. So similarly, we can also do the same thing if we have a base class. So this would be our base class. So base class is also called, what's the other name for the base class? Parent class. This is also called a parent class. There's another name. We used to call that one a few years ago. Superclass. So base class, parent class, or superclass. So that's the class which is at the higher level. And the class which is inheriting from the base class is called a derived class. Derived class. What's the other name? Subclass, child class, and you might find a few other names as well. If I have another class underneath here, if I have another class, so this exempt class in this case will become a parent class to this inherited class. So you can see the hierarchy, and this whole subject matter is called inheritance in object-oriented programming. What do you think? What is the use of object-oriented programming? Why do you want to use object-oriented programming? Why do you want to have a class over here with some basic or parent level rights or privileges to that class? Why do you want to give those kind of privileges? What could be the advantage in programming? Yeah.
Don't have to reprogram stuff. You can use what's already been written.
Sure. So you have spent some time analyzing, thinking about what employee should look like. So for your company, you have created that class after significant resources. You have spent a lot of resources. You have researched, these are the variables we need. These are the actions or methods we need. So once you have identified a generic employee class, then you can reuse it. However, there might be some specific issues, some specific things. And those specific kind of actions or attributes are not local to employee. There might be some other lower level classes. So you can create other specific classes, such as exempt or non-exempt or contractors, or many other types of classes can be created at the lower level, which might accept some of the high level attributes, but they might also create their own attributes and their own methods. So that's the whole idea in inheritance in object-oriented programming. All right. So in this chapter, our goal is to talk about inheritance. We just have started. We just discussed the derived class and base classes. We'll be spending a lot of time discussing those as well. How to define and redefine the member functions, how to examine the constructors and destructors, and especially when it comes to what if you have constructors at the lower level, constructor over here, and this constructor wants to access some of the things from the higher level constructors. So we'll talk about that one, and how the destructor works in base class versus and the derived class. We'll also talk about how to use the header file, which we briefly talked about last time. In fact, for your project number 1, did you create separate header file and CPP file?
Yeah.
Yeah, so that's the goal, that we are keeping our declaration separately and implementation separately. We'll be doing the same thing in the second project as well. And at the end, there's a very brief discussion about composition. We'll talk about composition. It's is our relationship versus has a relationship. We'll talk about that one. And some of the other principles of object-oriented programming, such as encapsulation, polymorphism, and so on and so forth. So you will see, conceptually, inheritance is a relationship or is our relationship. So whenever you hear inheritance in object-oriented programming is a relationship, what exactly it means by is a relationship? What do you think? Anybody has a book open? You want to read about it? Just one or two statements. What exactly it means by inheritance is a relationship and composition has a relationship?
It's derived from?
That's right. So it actually derives from the base class. So it is a relationship between those two classes, the base class and the derived class. And the other one, which we'll be talking about, aggregation or composition, has a relationship. It has slight variation between those two. So inheritance is a relationship. Every employee is a person. So if you have another class over here, and that class is called a person, so it's saying every employee is a person. So that's why it's called is a relationship. Every exempt employee is an employee. Every contractor is an exempt employee. So you can actually create that kind of relationship conceptually. So inheritance allows creation of new classes. And that's the beauty of the inheritance, that this base class has been identified, has been created, has been researched, has been analyzed. Now your job is to create a smaller, maybe a class which is more specific to your needs. So, and guess what? This employee class probably will be available in most of the cases. You don't have to redevelop this class. You can purchase it, or you can reuse your existing class, and that can be implemented in different kind of organizational, different settings. The future organizations will not be the same the way we are conducting our businesses these days. So if you have a base class already in place, then you can actually have more specific class underneath. So derived class inherits the properties of its base classes, and we'll see that in a lot of detail when we get to the discussion furthermore. Inheritance helps reduce software complexity. How come? How so? It reduces the software complexity.
You're not repeating code. You can just go back and higher level code.
Right. So if my dad has some attributes, I can access those attributes. So I don't have to have the ownership of all those attributes. I don't need to have recreate those things. Those are already available to me at the higher level. And this could be 1 or 1,000 of those attributes. Those can be easily accessed. You can have single inheritance and multiple inheritance. I understand single inheritance. What about multiple inheritance? What exactly it means by multiple inheritance?
You get attributes from multiple parents.
Multiple parents. That's right. Just like I get attributes from my dad and from my mom. So it's multiple inheritance. So initially we have single inheritance. So this exempt is only getting from employee. This employee is only getting from is a relationship between person and employee. So then you have all public members of base class and inheritors as public members but derived class. So all the public methods are available to the derived class. And here in your book it shows this example here. Shape is a parent class, circle is a child class or a derived class, and rectangle is also, because there are some attributes which can have some relationship between these kind of shapes. Now that would be silly if I put employee here, right? So when you're developing this kind of inheritance, you cannot just plug in anything you want. So there should be some kind of relationship. So here we have certain attributes. Then as an analyst, as a developer, I need to be smart enough that where exactly my classes need to reside. So the square, which probably looks like a rectangle, can inherit some of the attributes from rectangle class, so we can develop a square class. And how do we create the relationship between classes? So if I have a class called exempt, so let's say I have public class, or simply if I want to say, that's fine, public class exempt. So I can use this colon, and by using colon, then I can highlight what name of my parent class. So in this case, member access could be public, and the name of my base class, public employee. And if you're creating a relationship between some of the other ones, you just need to use, and we'll see an example where we can show multiple inheritances. What if you're getting from multiple parents? So private members of a base class are private to the base class. You guys okay with that? I'm going to repeat that statement. So if you have a private members here, they cannot be seen here. Okay? So your dad or your mom has some private data known to him or her. However, they might have some protected data. So the protected data, if it's identified as protected, it can be seen here. It can be accessed here. The protected data is still cannot be accessed from outside, but it can be accessed within that inheritance. So that's where this identifier will be used. And I'll show you an example. I can replace my private identifier with protected to make it accessible at the derived level. So derived classes cannot directly access the private data. However, they can access the protected data. And in many instances, you want to make it protected because you want to have give those privileges to the derived classes. So public members of a base class can be inherited as public or private members. Derived class can include additional members, of course. That's the whole idea. That's the whole idea that I have, let's say, a few of these methods here. That's a couple of them here. I can add additional members here, additional methods here. I can inherit these. If they're public, I can inherit these here. On top of that, I can add additional ones. Then later on, we'll be learning later in the chapter that there's something called overriding. So we'll be distinguishing between overloading and overriding. So that's the key. Those are the two keywords I would like to discuss later on: overloading versus overriding. And you'll hear these two terms in object-oriented programming all the time. So in fact, we have been using overloading. We have used overloading in the past, or you probably unknowingly used it. But I'll be distinguishing between those two in a little bit. Then it further says to redefine a public member function, cross-bounding function in derived class must have the same name, number, types of parameters. If derived class overrides a public method. So if I have a method here, let's say this method here is called print method. Print method, this is what it looks like. And I have another method here, which is also called a print method. And if I'm actually creating an exempt class or employee class, let's say in my main function, I'm sitting in my main function, I'm creating an object of exempt type, and I say call the print method. Which method should be called? Don't you think there'll be confusion because we are saying call the print method? So there might be some confusion.
Yeah.
So the compiler looks at the type of the object was created, and compiler reconciles it. Compiler says you created an exempt, so I'm going to be more specific. I'm going to call that kind of method. However, sometimes you can have the same name, but you will be able to call the parent method based on how you make the call. It becomes a little bit more complex. And this happens at the runtime. When the compiler is running your code, at the runtime, it makes that decision which method I need to call. So a derived class overrides a public member function of the base class, which means they have the same signature, but it can override. Signature means its header is the same. Then to call the base class function, specify the base class, use the scope resolution operator to highlight which method I'm trying to call. Function name with the appropriate parameter are used. And we'll see, right now it might be the verbiage and you might say, oh, I'm not really getting it, but you will see that how we make that call in our code. This is just our UML, and it talks about box type and rectangle type. I'm going to show you employees and exempt and non-exempt. I'm going to show you a different example. In fact, you know what? Let's actually look at it. So this is what I have on our Moodle site. And as I highlighted last time, you can expand them or collapse them. So here's my employee class. My employee class is my base class. I'm keeping it really simple just to see how it works. Then I can add additional members. This employee class has just a name. We can add additional attributes as well. Let's just keep it simple. And the name is a private data type. Then I have a couple of constructors. Here's my first constructor, which is called default constructor. If you remember from last week, this is a default constructor. And in the default constructor, I just want to make sure that I am able to invoke this constructor. So I'm just leaving some kind of a string there that no name is assigned to variable name. Name is a private data type. Then the second constructor takes one argument, n, of string type, and it uses to assign the value for name. Remember from the last week, the purpose of the constructor is to construct your object. So I'm trying to construct my object. And my object is really simple. All it has is just a name, and that's what I'm trying to do. Then I have a destructor. This destructor basically doesn't need anything in there. I'm just leaving some kind of statement there just to see if it is actually executed at one stage. Then I have a show method. Show method. This show method simply shows me, picks up some kind of message from the user, and then shows me the name of that particular object, whatever the object was created. I don't really need this message. I don't really need this argument. I'm just showing you that you can actually pass something to this particular method. And this class ends right there. Really, really simple class. 2 constructors, 1 destructor, 1 private data member, and that's it. And here, my exempt class is a derived class from employee. And this is how you can identify it. You can see that I have a relationship between exempt and employee. And here's the relationship. This exempt is a derived class. It's based on this employee class. Okay. Now, do you think exempt employees will have names assigned to them, given to them?
Yes.
Sure. But I already have identified this employee will have a name. So I don't need to redefine it. So this exempt employee can inherit the name from the employee class. You can also argue, well, employees can have many other attributes, such as IDs, such as date of birth, addresses, and phone numbers. I agree. We don't have space to add all of them, but definitely in a real employee class, you'll have those additional data members. Assuming this exempt employee will have some kind of salary, fixed salary. It's fixed, weekly, bi-weekly, monthly, doesn't really matter. Some kind of salary. Now you can argue all employees must get some salary. Not necessarily. Not necessarily, because some employees get monthly salary or bi-weekly salary. Some employees, they get hourly wages, right? So that's why we cannot leave the salary at the employee level. Now you say, well, in our organizations, all employees get a salary. I agree. If that happens, your employee class will not be generic enough. It's not at a higher level. You want to make your classes very generic so they can be implemented appropriately. What if you want to take this class, take it to another department, and they might have exempt and non-exempt and contract employees? Then in that case, your employee will not be able to, it will not be that useful in that case. So here what we are saying is I have a salary for exempt employee, and I can access the name probably from the employee class. And here's my first constructor. I'm just assuming the salary is 10,000. You don't have to give anything. You can just give 0. And then I'm passing to the second constructor the salary of this employee when I create that object of that type. I'm passing the salary. Salary will be assigned to this local private variable. Notice that I'm also passing the name. But the name does not even exist here. It's not there. It is at the higher level. How do I pass that name to the parent class? I can pass it just like when I created the relationship. I can pass this name. I can use the name of the class, and as an argument, I can pass that name. So what happens by doing this, it will call the appropriate constructor of the base class. It says, do you have a constructor which can take one argument of string type? And it says, let me look at it. So it finds that constructor, which looks like this, finds that constructor, passes that argument, and it captures that argument, sets the value of the name. So if you have some data which is not available at the derived level, you can pass it on to the higher level. Let's say you also had ID or some person ID. And person ID is at the much higher level than the employee. You can also pass that to employee, and employee can pass that to person. We don't do that in this chapter, but later on we'll see that you can actually pass the data to the few levels higher based on where the constructor can be found. So here, this is how you can pass the name to the base class. And that's just your exempt destructor. And then this one is very similar to what we had earlier on. This show method is exactly the same signature. It's a void function. The name of the function is exactly the same. And there's one argument. So it's very, very similar. Then I would like to display the name and the salary of this individual. Name and the salary of this exempt employee. In order to access the name, what do I do? I don't have the name available here. What do I do in that case? So I have to go and maybe access my base class, right? Mm-hmm. Now you can say, well, I can call the show of the employee class. And that's exactly you can do. I'm going to call the show of my employee class. So use a scope resolution operator. Because this show already is available here to avoid that ambiguity. To avoid any confusion for the compiler, you're saying, I'm going to call the show of my employee class. So then that show method will be called from the employee class. It is going to display the name. I cannot do this. This is illegal. Why this is illegal? I cannot display the name over here. It's going to give me an error message. Because name is a private. Name is a private data member. Yeah. So name is private, and I'll demonstrate that to you. As if I try to display this directly, it's going to say name is private. You cannot access it. And then I'll change it to protected. Then I'll retry it. Then we'll see that if we are able to access. Then the salary can be displayed here. Yes.
But really, you're displaying the name. It's just a matter of using the right pathway.
Correct. It's just that who actually has the privilege, who has the access to the data or those attributes. So it's just the encapsulation of the data. So, and we can argue, well, we are making it more complex for ourselves. In this example, it might look like that, but imagine if you have very, very large classes. Employee could be a very, very large and complex class. And then you have many derived classes underneath. So you're trying to simplify it. You say, you know what? Somebody has already created this very large class. I should not be wasting my resources and time to recreate this whole thing. So I can just simply use what already is available to me. And that's what we'll be doing 2-3 weeks from now. And that's what you do in Java as well. When you join Java class, what do? You have these hundreds and thousands of these classes available. You just start implementing them. Because you don't want to recreate them. Somebody else already created them for you. They already have identified all the data variables, all the methods. You just start implementing them. And then you realize, in your case, you need something more specific, which is not available at the higher level. Then you can create the specific things over here, things which were not available at the base class level. So it's just that the main concept, which I talked about last week as well, is that reusability. It makes your programming easier. Imagine if I want to create buttons and windows and graphics and all those things, it will take a very long time. Somebody has already created all these buttons and all these menus and all those things. I just learned how to implement them. Once you know how to implement them, how to call those classes, how to create objects of those classes type, then the programming becomes easier.
So if you really want to keep something like name private, you then have to really control who's using the program.
Right. So that's right. So if I make it private, yes, I'm just giving that privilege to the base class. But if I make it protected, then my underlying classes will have the access to it. So again, this comes to your organizational business rules or business procedures. Who controls what? So, John, comment?
Is it possible to so you have private, public, and protected. Is it possible to make a new type of category?
We have something called friends. We'll talk about it in a few weeks. But if you, what are your ideas? What kind of data member or identifier you want to create?
He was just talking about how you have something like name as protected, and
sure.
Then the derived classes can access that, and you may want to keep that secure. So maybe you come up with some other method for accessing the data. I guess that's kind of what I'm asking. Could we make that?
Yeah. There are other ways indirectly I can access. For example, if I have getters and setters, let's say in my employee class, I have some getters sitting there. I can call those getters from the lower level, like what we did last week. That's another way to access the data, right? So there are multiple ways you can access the data, but it's just that what method you're using, how you're trying to access the data. So I'm not sure I'm answering your question, but programmatically, or what's the right word, programmatically, you can probably create things that you can provide certain privileges, restrictions to the derived classes. You can probably do so. So is it possible you can create your own identifiers? Possibly. I have not thought about it.
Okay.
Yeah. So our non-exempt class will be similar. There are, yes.
I'm sorry.
Yeah.
Can you just refresh the original show message is showing a private information? Is that why it's a show instead of a print?
Right. So my first show in employee, this is my employee class. This show can access the name, as you can see.
Private?
And because it's inside the employee, so it has the full access because it's part of that class. However, when I get out, I come to the exempt class, which is a derived class. Here, I cannot see the name. This becomes illegal. So I can access it by calling the show method by clearly identifying that I'm calling the show method of the employee class.
So what is the show function doing in the original base class?
It's just showing the name.
Internally?
Internally.
Okay.
Internally, yeah. It's more like a getter.
Okay.
So it's just basically you are calling that method. It's just spitting out the results.
Okay.
Yeah.
So it's like making it available.
Available.
To the derived class to
Right.
gain access.
So it's, in other words,
Finding?
yeah, it's in other words, you are walking on the street. I'm not sure it's the right thing to say on the camera, but you're walking on the street and you see someone. You say, "Will you marry me?" And you will probably not get a good response because you did not use the proper method. But after you spend some time, then you ask the same question to the same person. Answer might be different. So it's just that how do you access the data? How that data can be provided to you? So if I say directly, show me the private data, answer is no. If you go through the proper channels, then it's available. in the non-exempt is very similar. The only thing different is this time in non-exempt I have wages and hours, and that's what I'm doing in my first constructor. I'm just initializing to nothing, then I'm initializing to the values provided to me. This name will be sent to the higher level, as you can see, just like what we did in the exempt class. And then same thing over here, I'm displaying the data. Okay, so those are our three classes. And these are the classes, this is what they look like. Now, what I'm doing in my main function, I'm creating EMP1, which is, what's the name for EMP1? What's the name, what do we call that? Object. That's my object. What's the other name for the object? Instance. So I'm creating an instance. So you want to use those terms. When you see someone in the hall, in the lab, if you want to impress them, just use those words. Don't say this thing. So that's my object. They'll get impressed. Okay, so I'm just teasing you guys, but so that's my object of employee type. You say, well, I don't know what you mean by employee one of employee type. Well, tell them, what if I say this integer x? Do you understand this integer x? Even the non-computer science people, they'll say, yeah, integers are whole numbers, or you can describe the whole numbers, and this x has the attributes or has the actions based on this integer. It can behave like an integer. That's exactly what we are saying here. This employee one has the attributes or has the actions, or it can behave like employee one. Now, employee one, when it was declared, or employee when it was declared, employee class, nothing was created. No data was created for that employee. We just showed our intention that we would like to have this for that employee. It was just like a template. However, when I say employee one, at that time, immediately compiler goes and creates its space in the RAM for those members of that class. And in fact, you can actually verify it. You can actually put a system pause and verify it, and it will show you that it goes and creates a constructor. Now here, employee one does not have any arguments. Notice there are no arguments. So it's going to call the default constructor. Because if I pass the argument, it's going to call a different constructor. In this case, I do pass an argument, and it calls a different constructors because I have two constructors. One constructor does not take an argument. One constructor takes an argument. So in this case, the second constructor will be called. In this case, the first constructor will be called. So you guys are okay with that one, right? I really, really want to move forward with this because we'll be going through this in more complexity in the future chapters as well. Then here I call my show method just to ensure this employee object has the access to the show method. Really simple stuff. And here I call my show method, and I just want to check I'm able to access. Then I create a staff one of this type. Staff one of this type doesn't have any arguments. And I just want to call the show method just to see what happens. Which show will be called. Now here I'm saying show is part of staff one. So looks like it that I'll be able to call my exempt show method. And then I do something similar. My staff two has, staff two is also an exempt, but this time I'm passing two arguments. One for the name, which will be sent to the main class or parent class. One will be the salary. And I'm just checking again what happens when I call the show method, just to verify it. Then I create non-exempt employee. Non-exempt employee does not have any argument in this case, and I call the show method. Really simple stuff. Okay? Really simple stuff. Let's test it. So when I run this one, and let's verify each step by step. So I'm going to put right next to it. And here is my first one. Here's my first one. And because I passed the message regular, that's why you see the regular. For regular employee, name is no name. Tell me why there's no name here. because
You
we
act
are-
as a constructor.
that's right.
Because
Because of my object, there was no argument. So no name was passed. So I left the default name, which is no name. For regular employee, name is the second one. So this is our second object, which is employee 2. So we successfully passed the name. It was captured, and the value was set for the name. For exempt employee, which is staff 1, no name was passed, and the default salary of $10,000, which was part of my constructor. Very poor idea, very bad design. But I left $10,000 right there in the constructor. In a real program, in a real class, you don't want to do that. But I just left it there just to see what happens if I do not pass any arguments, what will happen. In the next case, for SOFA, by the way, SOFA was one of my students, really, really good student, was very successful later on in the industry, so he did really well. Many of the students are doing really, really well, and some of you will be doing very, very well. So here, SOFA, I passed the SOFA, which is right here, right there, and passed his salary, and salary was captured, name was captured, and name was actually at the higher level. It was passed on and successfully executed. For the non-exempt employee, no name and hours were not passed. Nothing was passed. So as you can see that we were able to access our derived classes as well as our base class. This name is being displayed, and this name is being displayed because I was able to access the higher level. So what I'm referring here is I'm passing on this this name here, right there. I'm passing on this name here, and that's where the name was passed on to the previous function, and I was able to display that show method here. Okay? Real simple stuff. So what was our project 1 all about? Project 1, you had to create what? Bank account, right? So do we have just one kind of bank account, or we have different types of bank accounts? So you can have so many different types of bank accounts, right? The two main ones are checking and savings, right? So is it a good idea to put everything in bank account? No. That will be, so you want to have a base class bank account, you want to have a derived class checking account, another derived class savings account. Then under checking, do you think there could be other types of checking accounts? There could be so many different types of checking accounts. Then that could be the third layer. So in fact, that's exactly what we'll be doing in the second project. We'll be creating inheritance based on your previous bank account. So we'll be adding additional levels to see that if we are able to call them. I'm going to pause this lecture here for a minute. Thank you, guys.